Hi, welcome, this is Clemens at Elektor. In this video we will have a look at the GreatFET One board from Great Scott Gadgets. This board is designed around an LPC4330 microcontroller from NXP. This is a dual core device with an ARM Cortex-M4 and an ARM Cortex-M0 core. This MCU has plenty peripherals, of course. It has Ethernet, it has CAN. It has two USB ports that can be device, host and on the go. It has a cryptography engine, it has I2S, a SPI flash interface, it has a floating point unit and much more. Most of the GPIO port pins of the MCU are brought out onto these two 40-pin connectors. On these extension connectors you can plug a daughter board, which are called neighbors. You can find designs for a few neighbors on GitHub. Note, by the way, that when you go to GitHub that the GreatFET One board is also known as the Azalea board. Besides the MCU, there is also a 16 megabit SPI flash memory chip on board. The GreatFET One has the same size as an Arduino Uno. Like Arduino, the GreatFET One is totally open. You can download the hardware design files and the source code all from GitHub. The GreatFET One comes preloaded with a special firmware that allows it to be controlled from a host computer. It runs some sort of a GPIO server to which the host can send commands to switch on and off pins and to read the pin states. The firmware also has some more complex protocols built in, for example communication protocols like SPI or I2C, and it even has logic analyzer capabilities. An MSP430 debugging over JTAG seems to be supported as well. SDR fans will appreciate the GNU radio interface. With the phase dancer library you can use the board to emulate USB devices. Please have a look at the GitHub repository to see what more is being worked on. USB port 0 is used to connect the board to a computer. The other USB port is available to connect it to other devices. When the board is connected to a host computer that has the GreatFET One libraries installed, the host can detect the board automatically and you can start controlling it right away. Several commands are available for controlling it directly from the command line, which saves you a bit of programming for simple tasks. Of course, I tried out all the tutorials and most of it worked well. I installed the board on a Windows 10 computer and that went fine. The board was found and I could get some information from it. However, the LED blinky example did not work. It got me a key error about LEDs. The GPIO example on the other hand worked fine. As it turned out, the problems I was seeing were due to the outdated firmware I was running on my board. I downloaded the latest version of the firmware from GitHub because it was not included in the library, and after refreshing the board the LED started blinking. The SPI example was not of much use to me as I do not have a compatible RGB LED strip, but I tried it out anyway and discovered that way that I needed to install the bitstring library first. The logic analyzer example is unfortunately not finished yet and is still full of fix me comments. Anyway, I wired the board up as suggested and tried to send data on the SPI port, but whatever I did I always seemed to capture the same 22 bytes. When I tried the SPI example string I ran into an error, but luckily I could fix that by adding an encoding to it. If you install a cross compiler you can program the LPC4330 directly. That way you have full control over the MCU and you basically turn the board into a powerful MCU breakout board. Because the instructions for installing the cross compiler are only given for Linux, I did this on a Raspberry Pi 4. Doing so I run into a version conflict with the prompt toolkit, and this was due to Python 3.8, which is recommended by the tutorial. But in fact you have to downgrade the prompt toolkit to a version below 2 to make the installation complete. Once I had the cross compiler installed, I could compile the firmware for the board without any problems. So here ends our overview of the GreatFET One board. I think it's a great and powerful board for people who are into serious hacking, but it's definitely not a board for the faint of heart. As with so many open source projects, the documentation is only useful and available up to a certain level, and if you want to go further you are mostly on your own. And of course, a good working knowledge of Python is really recommended. Okay, that's it. I hope you found it interesting. Thank you for watching.